Well, this is the basically how to solve or how to work through this practice that I have set up for you. Basically, there's a couple things you could do. First of all, if you have access to a printer, you can just print this out and then do it on paper if you like, or you can use your stylus and then just, well, write directly onto the Word document. You'll have to save your own copy, but you can do the solutions right on it. If you run into a problem with that, sometimes what I like to do is actually just print it to the OneNote, and OneNote is actually pretty nice for writing in. It's a little bit better, I found, than trying to write in Microsoft Word, but whatever works for you. So let's get going on this. So this is Ohm's law practice. Excuse me. What I like to do first of all is I'd like to write the equations that I want to use, that I know I'll use, at the top. That way I just don't have to remember them every single time. And so the equations are V equals IR. So voltage is equal to current times resistance. We have current is equal to, so you have to be voltage divided by resistance. And resistance is voltage divided by current. And it's one of those things where, like I said in the previous video, if you make the little triangle, you could just do one of these things too at the top of the page. And if you make this little triangle and then you cover up the thing that you would like to solve for, then that's a good reminder about what, like how to do it. So if I want to solve for current, I cover up the I, and now I know it's V divided by R. If I want to solve for voltage, I cover up the V, and now I know it's I times R. If I want to solve for resistance, I cover up the R, and then it's V divided by R. So I like to write that, just keep it handy, basically, is what I like to do. So looking at the questions that I have here, we want to know the potential difference. And potential difference is just another word. Actually, it's the correct definition, the correct wordage of voltage, what voltage is. So we want to find voltage. We have a current of 8 amps, so that's going to be our current, I. And it says our resistance is 64 ohms. So I already have that preset up for you. We're trying to find voltage. We have current and resistance. So what do we do? Which equation do we use? Well, like I said, I like to have all three just kind of there for me, and I get to choose that one. And so I'm going to choose V equals I times R because I'm trying to solve for voltage. So I just put the numbers in, and now I'm kind of used to using parentheses, and so I'm going to amps. Got to make sure that's in amps every single time. 64 ohms. It's a terrible ohms, but it is what it is. And when I multiply that together, I get 64 times 8.0, and that is going to be 512 volts. So 512 volts is going to be my answer. All right, so that's the first one. Now we have an electric toaster. This is the process you follow for all these. So identify what V, I, and R are in the question, and then just work through it. So resistance, so that's going to be our R. What's going to be the current? So it says actually what current, so that's going to be our I. And we have a 120 volts, so that's pretty obviously our voltage. So we will write those out. Now, you know what? I'm just going to, I'll just erase that or cross it out. I'm just going to keep in the same order as I did above. Voltage is 120. What do I do next? Current is the question mark, and resistance is 12. So you don't always need to go VIR, but you know what? It's nice to get in the habit of something, and so it doesn't really matter though, because you just have to identify which one you don't have. So we don't have current, so I'm going to use this equation, I equals V over R. So current is V over R. I'm going to write down which equation I do use. So then I just plug in current is voltage, so 120 volts divided by resistance, 12 ohms. Was actually pretty decent this time. So 120 divided by 12, I don't even think I need to check my calculator on that one. That's going to be 10, and current is amps, so so it requires 10 amps of current. All right, so let's do this. Oh, look at how I got this little thing here. This is just bugging me. So that's even worse. Well, let's just continue on as we were. So we have an electric current, and I lost my pen. There it is. Electric clothes dryer connected to a 230 volt source. That's obviously our voltage. And resistance of 9.2. That'll be our R. We want to know how much current. So going to be our I again. So we should do this just like we've been doing it. Keep with the pattern. And you won't mess, you'll be less likely to mess up. So voltage is 230. I is our question mark. And our resistance is 9.2 ohms. So once again, we're going to use the I equals V over R. And I plug that in. And this isn't too tough, right? So 230 volts divided by 9.2 ohms. And this one I am going to have to put in my calculator for some strange reason. I can't do 230 divided by 9.2 in my head, although it does give me a nice number, 25 amps. Okay, and I do have the key on the bottom of this. I could be checking that, but I'll probably do that when I'm done. So those are the first three. I'm going to just kind of scroll down here so we can see what else we have. There's a couple more, 3 more actually. So we'll leave it like that. So we have a portable radio connected to, which is nice to have in case of emergencies, a little portable radio. That doesn't depend on the web because sometimes the internet goes out. But we have a 9-volt battery voltage. It draws a current of 25 milliamps. In other words, 0.025 amps. How did I get that? Well, to go from milliamps to amps, 25 milliamps is I'm going to divide by 1,000 to give me the 0.025 amps. Okay, so divide by 1,000 to go from milliamps to amps. You have to be in amps because amps it's the relationship. I mean, the relationship between voltage, current, and resistance is measured in amps, volts, and ohms. So we want to know what is the resistance. So that's going to be our R. And if we go with the same pattern, V is equal to 9.0 volts. I is going to be 0.025 amps. And resistance will be our question mark. Okay, so I have the equations written at the top, and so I want to find resistance in this case. So it's going to be resistance is V divided by I, and plug the numbers in. And once again, the math itself isn't too tough. Now I'm in the algebra mode, so I just got to go 9.0 volts divided by 0.025 amps. And when I do that, I find out the resistance is 9.0 divided by 0.025, 360 ohms. All right, that ohms character does take a little getting used to. It's a Greek letter. You might not be used to drawing it, and that's okay. You can see I'm not a really great master at it either, but that's okay. So, excuse me, a large tube in a television set. So like talking old school here, has a resistance of 50 ohms. You can just tell because of the ohms, that's resistance. It draws a current of 160 milliamps. We're gonna have to deal with that by dividing it by 1,000 again, because it is in milliamps, it's 1,000. What is the potential difference across the tube? Well, if you remember from question 1, I mentioned that is going to be volts. So that's what we're trying to find. So V is equal to our question mark. That's a 3. Let's not do that. 3, that's our question mark. Current is equal to 160 milliamps. So I'm just going to double check my calculator because I don't necessarily trust myself, or rather it's always good to double check yourself. And it is what I thought it was going to be, but you know what? There's no shame in using a calculator, because if you get too overconfident, you're going to make mistakes. So double check everything. It's okay. And the resistance is 50 ohms. So now V, I want to try to find V, and I look up above and I see it's V equals I times R. I've already gotten that one written out. So V is 0.16 amps multiplied by 50 ohms. And whoop. So 50, so the voltage is 8 volts. Okay, so there's the next one. Now the last one, even if you got to this point, you might have gotten this part and got number 6 and be like, well, I don't even know what's going on here. So number 6 is kind of a two-part question, honestly. It says that you got an iron, and one thing I would suggest in this time, if you have time, is to find out how an iron works. If you haven't tried one yet, it's very handy for your clothes. But an iron uses 120 volts and draws 5.0 amps. But it wants to know if it's accidentally connected to a 240 volt. So we have like apparently 2 volts, and this is current, and here's volts again. What's the current going to be at the higher voltage, and what's probably going to happen to the iron? Well, like I said, it's sort of a two-part problem, because over here the original like tendency of a iron is to be plugged into a regular 120 volt outlet at 5 amps, and so what we could do is we could figure out the resistance of the iron. So V is 120 originally, I is 5.0 amps, and we could find the resistance here. So resistance is V divided by I, and so if I calculate that out, so it's going to be resistance is 120 volts, that's a 0, divided by 5.0 amps. Once we figure out this resistance, we can just plug it into the other one and see what the current's going to be. So 120 divided by 5, so that's going to be, it's got a resistance of 24 ohms, all right? So that is going to be like, now we know the resistance of the iron. It's going to be the first part of our problem. So now, and you may have been actually astute enough to figure this out, because if you think about it, if you got 120 volts and you get 5 amps, and now suddenly you have double the pressure, the electrical pressure, it's pushing twice as hard. Take a quick guess. What do you think the current's going to be? How much flow do you think you're going to get if you're pushing with twice as much pressure or force, if you will? If you said 10, well, you're right, and here's exactly it. So now our voltage is, that's a V, by the way. V, oh, that's the worst V ever. V now is 240 volts. Our current is what we're trying to confirm here. We're thinking it's going to be 10, and we know that the resistance of the iron is still 24 ohms, because that's it's an iron, and it doesn't change its resistance. So I is equal to V divided by R, and so I is equal to the 240 volts, put that in parentheses just because, and divided by the 24 ohms. And like we said, 240 divided by 24 is 10 amps. So this is going to be the new current going through the iron. And if you get 10 amps running through something that runs on 5 amps, probably what's going to happen is going to be destroyed. It'll probably burn up. It'll probably cause a fire. Who knows? Don't go plugging things into bigger, stronger voltage outlets. That's why they look funny. Like a 240 volt outlet will look something like this. It'll have like the 3 prongs instead of it'll look different. If you've ever seen one, you know what I'm talking about. All right, there's different configurations, but that's one way to do it. You also sometimes see it like that, but it depends on the outlet you're looking for. So that's it. So that's how you solve these this practice. If you have any questions, of course, just definitely hit me up, and I'll see if we could help. See you when I see you. Good luck.